Hello and welcome. This is problem 7 of the physics final exam review of Princeton. I am Jerry and I'm going through the problems within this exam. So to problem 7. A man is sitting in a boat on a swimming pool. In the boat there is a rock of mass m equals 100 kilograms and density and rock density of 5 times 10 to the 3 kilograms divided by meters cubed. He throws the rock into the water. By what amount and in what direction will the water level of the pool change? The density of water is 1 times 10 to the 3 kilograms divided by meters cubed, and the area of the pool surface is 50 meters squared. So we have our known variables here, and we also have these equations. Now these equations are not in the formula sheet, but they're just something you should know. You should know that the density is equal to the mass divided by the volume, and that the displacement will be equal to change in volume over the area. And the second equation you should know because you can see that volume is in meters cubed. Well, you don't see it, but you should know that. And that area is in meters squared. So if you do meters cubed over meters squared, you're going to get meters. Cross that, that becomes a 1. So that is what we're looking for. We're looking for the change in meters, the displacement. So we have some water, and say it's, let's just make it flat to make life easy. Say it's at this level before the rock goes in, and then hypothetically the rock goes in and it goes up to here. It raises a little bit. Etc. You know, it's not exactly true, but sort of that's all we care about, the change in height that occurs. Okay, so for this equation, the more applicable form of it will be that V is going to be equal to m over density. Okay, so let's begin. And look at the question. It says, by what amount, in what direction will the water level of the pool change? Now, what we care about is the change in volume in before and after the rock goes into the water. Now before the rock goes into the water, let's have a big M and a little m. The big M will be the boat and the person, while the little m will simply be the rock. And this, the density that we're going to use is the density of water. And the reason we use the density of water is because at this point, the pool has nothing in it except for water. So density of water is the only thing that causes the displacement to happen. Now let's just say that m is equal to 0. It doesn't equal to 0, but in this case it does. I'll explain why in a moment. But if we do that, we can solve it, and we would get 10 to negative 1 meters cubed. This is the initial displacement that occurs. So it raises a little bit. The boat and the rock pushing down in the water raises the total surface level of the water a slight bit. Now for V2, we have m, big M, the boat and the person, divided by water, plus little m divided by density of rock. And this is because while the rock is in the water, the density related to the rock is what causes the raise in surface level. So now the rock is not affected by the density of the water, it is only affected by the density that is innate inside of it. Now, again, because this is 0, we can just cross this out, and that kind of shows why it's 0, because in this case, we could have m over pw plus m over pw. So yeah, we just have it in both, so it's kind of irrelevant. Okay, so then if we do this, we would get 10, or 2 times 10 to negative 2 meters cubed. And it makes sense that's a little smaller because the density of rock is larger and it's being divided by, so that we get a smaller number in the end. And then for the displacement, we can do the change in the volume divided by the area. Change in volume being V1 minus V2 over the area, and this will give us 1.6 times 10 to the negative 3 meters. Now, because the second displacement, when the rock was put in, is smaller, this means that it decreases by this, that this goes downward. the surface, what it says, the direction that the water level changes. It goes slightly lower than it was when the rock was in the boat. So you can say that when the rock was in the boat, say we had this level. When the rock is out of the boat, it's to say it's a little bit lower. And that's the end of this video. I hope you enjoyed it. I'll be going over more problems soon. Thank you and goodbye.